What is the exact differential equation? A differential equation obtained from its primitive or solution directly by differentiation is called the exact differential equation. For example, suppose we are given equation of curve y here x y square equals to c. And if we differentiate this equation, so we will get here apply the product rule for differentiation. So first term as it is derivative of y square, second term's derivative is 2y dy plus second term y square as it is derivative of first term is dx equals to 0. Now see we get the differential equation. So by using solution if we find the differential equation, so this is the differential equation getting by differentiating this curve. So this differential equation is called the exact differential equation. Here, if we solve this differential equation, then without multiplying any integrating factor, you can find the solution. So again, if we have given any differential equation, and if we no need to multiply any integrating factor, we can directly find. We are able to find the direct solution. Then again, this type of differential equation is called the exact differential equation. But if we are given the differential equation and to check whether our given differential equation is exact or not, so by definition it will be difficult task. So how to test whether our differential equation is exact and not? So for that we use the necessary sufficient condition theorem. That theorem proof I have already discussed in the previous videos, so you can watch that video. Link of that theorem is given in the description box. Theorem says that if we are given the differential equation in the form of m dx plus n dy, here m and n are functions of x and y, it is any form of x and y, and if this mn satisfied the condition that is del m by del y is equals to del n by del x. If del m by del y is equals to del n by del x, then our equation, let's suppose this is our equation 1, then our equation 1 is called exact differential equation. What an example on exact differential equation. So let's say the first example, solve the equation 2xy cube plus y cos x dx plus 3x square y square plus sin x dy is equals to 0. Here we have given the differential equation, but we don't know about whether it is exact or not. So we have to compare this differential equation with our mdx plus ndy equals to 0. If we compare this given differential equation with this differential equation, then the coefficient of dx is called m. It is just a notation. So m is equals to function 2xy cube plus y cos x, and our n is equals to 3x square y square plus sin x. Now to test whether our given differential equation is exact and or not, so for that we have to differentiate this m and n partially. So differentiate partially with respect to y. Here m is a coefficient of dx, so you can differentiate that m partially with respect to y. And here this n we have to differentiate partially with respect to x. So see here, when we are differentiating partially, that means we have to keep remaining variable as a constant. So here we are differentiating with respect to y, so we have to keep x as a constant. So if our x is constant, so we know that if we find the derivative of ax, so at the time of derivative of ax, this a is a constant. So if any constant in the multiplication, we have to take that constant as it is and derivative of variable with respect to that x. Suppose we have only given the constant and we want the derivative of that constant. So we know that the derivative of constant term is 0. So derivative of constant is 0, but if that constant in multiplication, so we have to take that constant outside and derivative of function. So similar way, when we are differentiating with respect to y, so our x is constant. So in derivative of m with respect to y is 2x is in multiplication, keep this term as it is. Multiplication constant term we have to keep as it is. Derivative of y cube is 3 y square plus here cos x. Cos contain x variable, so it cos x in multiplication, so keep as it is. And derivative of y with respect to y is 1. So we get derivative 6x y cube square into cos x. Let's suppose this is our equation number A. Now similar way, we have to differentiate our n with respect to x. So del n by del x is equals to y term is constant. So in first term 3y square is constant. Derivative of x square is 2x plus here sin x containing x variable. So differentiate this sin. So we get derivative of sin is cos x. Now simplify this term. So 2 into 3 is 6x y square plus cos x. Suppose this is our equation number B. Now observe this equation A and B. It is clear that these derivatives are equal. So therefore, from equation A and B, it is clear that del m by del y is equals to del n by del x. And if this condition is hold, so this imply given differential equation is given differential equation is an exact differential equation. Now, if our differential equation is exact, then we require the solution of this differential equation. And we know that if our differential equation satisfying the condition of exact, if and we know that if our differential equation is exact, then the solution of this differential equation is, so therefore the solution of an exact differential equation is, it is integration of m dx. We have to take y as a constant plus integration of n dy terms of n not containing terms of n not containing x equals to integrating constant c. So put the value of m and n. So here integration of m. So from our equation m is 2x y cube plus y cos x. So here 2x y cube plus y cos x into dx. Here y is constant. Next, from n we have to take the term without contain x. See here n contain two terms. First term contain x and second term also contain x. So there is a no term without containing x. So here second integration contains 0 dy equals to integrating constant c. Now integrate this term. So here y is constant. So from first term 2y cube is outside. Integration of x is x square by 2 plus here y is constant outside and integration of cos, here integration of cos x is sine x. So it is a sine x is equals to c. Now simplify this term. Here 2 to get cancelled. So final answer is x square y cube plus y sin x is equals to c. Dx is equals to y upon 1 minus x square y square dx plus x upon 1 minus x square y square dy. here it is not mentioned that solve this differential equation using the exact. That means we have to check whether it is exact or not. If it is exact, then we can use the method of solving exact differential equation. Otherwise, you have to apply the another method, and that another method we are also discuss in this lecture. So let's see how to solve this example. First of all, we have to convert this equation into our standard form. Standard form, that is a m dx plus n dy equals to 0. So whole term we have to shift in left hand side. So I will shift this dx in right hand side. So here we will get y upon 1 minus x square y square, and this dx if we shift in right hand side, then that will be the minus dx, and from first or this dx if we take dx common, so we will get here minus 1 dx plus x upon 1 minus x square y square dy equals to 0. So here if we compare this equations with this general form, then we get m is equals to y upon 1 minus x square y square minus 1, and n is equals to x upon 1 minus x square y square. Now differentiate this equation partially. Here m we have to differentiate partially with respect to y. So I will write this step in the next page. Here our m is y upon 1 minus x square y square minus 1. And if we differentiate this m partially with respect to y, so the y is contained in numerator as well as in denominator term. So we have to use the quotient rule, that is derivative of u by v is equals to v as it is derivative of numerator term minus numerator term as it is derivative of denominator divided by v square. So here del m by del y is equals to denominator term 1 minus x square y square as it is, derivative of numerator term derivative of y with respect to y is 1 minus numerator term y as it is derivative of denominator. So denominator 1 minus the 1 derivative is 0, x square is constant, so minus x square multiplication term as it is, derivative of y square is 2y divided by 1 minus x square y square whole square. So therefore, simplify this term, 1 minus x square y square minus, here multiply by this minus y. So this minus minus plus. So plus 2 times x square y square divided by 1 minus x square y square whole square. So therefore, it is a 1 plus x square y square, this minus x square y square, and plus 2 times x square y square, that is a 1 plus x square y square divided by 1 minus x square y square whole square. Suppose this is our equation number A. The similar way we have to differentiate n partially with respect to x. Del n by del x is equals to, here division term 1 minus x square y square as it is, derivative of numerator term is 1 minus numerator term as it is derivative of denominator is 1 minus x square y square, and its derivative is minus 2 times x y square divided by 1 minus x square y square whole square. So here 1 minus x square y square minus x minus 2 times x y square divided by 1 minus x square y square whole square. Simplify this term. So this minus minus plus 2 times x square y square, and this x square y square. That means it is a 1 plus x square y square divided by 1 minus x square y square whole square. So here this is our equation number B. So if we observe equation A and B, then again the right hand side is same. That means left hand sides are equal. So from So from equation A and B, it is clear that del m by del y is equals to del n by del x. Differential equation is exact. So therefore, the solution of an exact differential equation is, and it is a general solution, it is a integration of m dx plus integration of n dy equals to c, that is integrating constant, and here in m we have to take y constant, and in n we have to take the term not containing x. So here put the value of mn. So from our given equation, m is our y upon 1 minus x square y square minus 1. So here y upon 1 minus x square y square minus 1 dx. Here y is constant, and from n we have to take the term without containing x. So n contain only one term and that term contain x. So without x term is not in contained in n, so it is a 0 integration y is equals to integrating constant c. Now here y is constant, so numerator y is constant, we can take outside. Integration dx upon 1 minus x square y square minus integration of 1 dx equals to c. Here we have to integrate this term, and we know that use the formula, that is integration of dx upon 1 minus is x square is equals to 1 upon twice a log of 1 plus ax upon 1 minus ax. So using this formula, here y as it is 1 upon twice a that means coefficient of x, so it is coefficient of x is y. So 1 upon y upon 2y log of 1 plus xy upon 1 minus xy minus integration of dx is x equals to c. This y get cancelled, so final answer is 1 by 2 log of 1 plus xy upon 1 minus xy minus x equals to c. In some book, this answer may be found in the form of, in some books you may find this answer in the form of x minus 1 by 2 log of 1 plus xy upon 1 minus xy is equals to c dash, where c dash is a minus 1, because from this term if we multiply throughout by minus sign, so we will get this equation that c dash is nothing but, here our c dash is minus c. So both answers are correct.